Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the problem solved on the basis of, look at the chapter number 8, last chapter we are discussing, that is the spectroscopic problems based on UV, IR and PMR spectroscopy. UV means ultraviolet, IR means infrared and PMR means proton magnetic resonance. These are the full form, and each and every spectroscopy play an important role in elucidating the structure of the organic compound, and UV spectroscopy provides us the information regarding the carbon-carbon double bond, whether it is in a isolated form or the conjugated form. That type of the information we are generally getting from the UV spectroscopy. From IR spectroscopy, what kind of the information we are getting? From IR spectroscopy, we are getting information regarding as a functional group. There are different functional group available in the organic compound. By using this spectroscopic method, we can quickly identify, or we are getting very easily information about the functional group. And PMR spectroscopy and proton magnetic resonance spectroscopy, it is a very important, because all kind of the information regarding as a proton, because each and every organic compound along with carbon atom always have a hydrogen atom, and therefore by knowing the environment around the proton, we can easily deduce the structure of the organic compound, and that's why it is very important as far as to identify, because from UV and the IR we are getting as a partial information about the structure, but by knowing the PMR spectroscopy we are getting full information about the organic compound. And yesterday we have solved one of the problem. Now while solving the problem, because look at here the question, how the nature of question in exam assign structure for the organic compound with the following data. They will provide you the data. By knowing that data, from that data you have to calculate the structure of the organic compound. Let us see here what the data they are providing. They are providing as a molecular formula. MF is nothing but as a molecular formula they are providing over here. This is a problem number second over here. So second problem, molecular formula is given C9H10O. This is a molecular formula is given. Another one, UV also given, UV ultraviolet data also provided, that is a 260 nanometer, 260 nanometer, which is a lambda, 260 nanometer, that is given, nanometer, epsilon 220, that is a data provided us. Then IR also given here, IR infrared spectroscopy, which is also provided 1715. Then I think before okay, let it be before that, the problem number second, this we will see later on. Before that, we will see the another example over here. So that this is the simplest example we are going to consider here. Here the molecular formula C10H14, C10H14, which is the molecular formula, and here UV also given, ultraviolet rays, lambda max will be 255 nanometer, and IR values are given, IR also given, IR is equal to 3100, 2900, I think 29110, then 715 per centimeter. That are the IR values are given. Then PMR data also provided, PMR data which is given, that is 1.8, here 1.38 delta in bracket singlet 9H, singlet 9H, and B is given, what is that, 7.28 delta, 7.28 delta in bracket, that is a singlet 5H, singlet 5H. If you observe these data carefully, here molecular formula is given C10H14, UV also given, lambda max 255 nanometer, IR values, stretching frequencies are provided, 3100, 291, 10, 700, 715 per centimeter. Similarly, PMR data also given, 1.38 delta singlet 9H, 7.28 delta which is also as a singlet, and 5H. Now, what is our, yesterday we have discussed one of the problem very clearly. How do we solve that problem? That we already discussed in our previous lecture. So let's see over here how we can solve this problem. First of all, look at the molecular formula. While answering first one, you have to calculate site of unsaturation. How to calculate site of unsaturation? Here you remember C10, let me calculate here properly, C10H14, which is a molecular formula is given, and from this molecular formula we come to know that it is a hydrocarbon. Why hydrocarbon? Because the organic compound which is made by carbon and hydrogen, that type of the organic compound are known as hydrocarbons, because it containing carbon and hydrogen. And now this is a molecular formula is given. There is a, then according to general formula of alkane, what is that? CnH2n plus 2. That is the general formula of alkane, that rule we are applying here. Then n is equal to what? You have to take n is equal to 10 over here. Whatever number of carbon atoms are there, you should have to consider n is equal to that one. And now C10H, 10 into 2, 20 plus 22. H is a 22. If your compound is a saturated, it should have a molecular formula is a C10H22. But look at here, you minus this figure from here, C10H14, and after subtracting the value, C10 get cancelled, C22 and this one, it remains here is 8. 8 is a total number, you have to take an integer number. And now as we know that because we are determining as a site of unsaturation, unsaturation means carbon-carbon single bond, and for hydrogenation we required as a 2, and that's why we are dividing by 2. Now what is the answer comes here? Answer comes as a 4. And as at the beginning I already told you that if the site of unsaturation is a 4 or above 1, definitely you think about it, account for the benzene ring. Benzene ring, because one ring and there are 3 alternative carbon-carbon double bonds are there, and therefore it is the total site of unsaturation present in benzene ring are 4, and therefore there is a possibility. You have to think like this. So we got the site of unsaturation is a here is a 4. Now second problem. Look at here. UV is given. UV data. UV is given. The UV data is provided over here. The peak at lambda max 255 nanometer indicate presence of benzene ring or presence of conjugated double bond or benzene ring. That's the information we are getting from this UV. And now third point, IR, the absorption peak at 3100 to 29100 per centimeter is due to CH stretching frequency, and which is generally found in any organic compound. And the fourth one, that is the IR absorption peak, the IR absorption peak at 750 per centimeter indicate presence of monosubstituted aromatic compound, substituted aromatic compound, aromatic compound or aromatic ring, you can call it aromatic ring, and therefore the partial structure, and therefore the partial structure may be this one, C4 and H10, because 6, 10 here 5 and remains as a 10. So this is a partial structure of this compound. Now let us move on to the next fifth point over here. Let me clean here. Fifth point, what is that? Fifth point is here, the singlet at PMR data. Now is PMR data, the singlet at 1.38 delta corresponding to 9 protons indicate presence of 3 CH3 group. 3 CH3 group. 3 CH3 group, methyl groups are there. And now, next point we are going to see over here. This is a side chain actually. Now, point number 6. The singlet at 7.28 corresponding to 5 protons suggest presence of phenyl group, phenyl ring, suggests presence of phenyl ring, which is C6H5, right? C6H5. By considering all above points, now we can write by considering all above points, following structure is assigned to the given organic compound. So in this way we can write now. So we know the structure of this is this one. Here we can write either this side, here CS3, here CS3, and here CS3. Look at, this is the aromatic compound 7.28, the aliphatic compound which is 1.38 delta value. This is a singlet, this is also as a singlet, 5 protons are there, and this is a tertiary butyl benzene. This is the name of this compound which we got over here. So in this way, in this systematic way, you can solve the problem based on it. Look at here, UV 255 is due to the conjugation, carbon-carbon double bonds are there and aromatic rings are present. The peak is appear near about 255 nanometer. Now is a IR 31000 to 29100 due to the CH stretching which is present here in case of that saturated CH stretching frequency which is attached to the sp3 sp3 carbon atom, CH stretching frequency, and 700 to 750 peak as observed in the IR spectrum, that is due to that suggests the pattern whether monosubstituted, disubstituted or trisubstituted pattern. So this 700 to 715 per centimeter, that suggests the monosubstituted pattern of the aromatic compound, and that's why that is also proved. Now look at here 1.38 9EH singlet. Look at here, all these methyl groups are there. The middle carbon does not carry hydrogen atom, and therefore all the 3 methyl groups are identical, and whatever protons present on it, they are chemically equivalent, and that's why they give only one set of protons, and all the aromatic proton, 5 proton, all will give one set of protons. So there are 2 sets of proton, 2 signal. From that we come to know that there are 2 sets of proton, therefore 2 PMR signals are observed in a PMR spectroscopy, and that type of the information, theoretical information, we already discussed in our during that theory part. But here how that structure after drawing the structure, you have to match how this structure fulfilling these whatever data are given, whether that data is match or not, that is also you have to know how to match it. It's perfectly matching, and that's why this is the structure, this is a compound structure of, that is a tertiary butyl benzene. So in this way you can solve the problem based on that. Now let us move on to the next point. So third example we are going to discuss over here. So let me clean the word first, and then we will solve the remaining example. Now see example number 3. Molecular formula is given C9H10O, which is a molecular formula is given here, and from that we are going to find out the correct structure of the organic compound. The UV data also provided, which is 260 nanometer epsilon 220, that is a coefficient given. Now is IR values are given, IR 1715, then 1519, 5050, 1590, 5050, 1550, then 1400 per centimeter, 1400 per centimeter. These are the values are given, and PMR data also provided. PMR data also given, A, which is 2.09 delta, 2.09 delta in bracket, singlet 15 mm, singlet 15 mm, integrations are given. Then B 3.65, B 3.65 in bracket, singlet 10 mm, singlet 10 mm and C is given 7.25. C is given 7.25 delta. Here remember delta. Singlet J is equal to 6 Hertz. Singlet J is equal to 6 Hertz and 25 mm. 25 mm. So this is the data given us, and from that we are going to solve the problem. Look at the problem once again. Molecular formula is given, UV data also given, IR values also given, and here PMR data also provided, and from that we are going to find out the correct structure of the organic compound, and it's very easy. And now what is our first, while answering first one, you have to calculate as the first point sites of unsaturation. So what is the site of unsaturation? Or for that we know that there are different methods are there. At T.Y.B.Sc level we are having two method, we are using two method, and out of that I am giving only one method which is commonly used. So it is very easy to apply it and to get the correct answer, and therefore I am using as a first method which is commonly method. According to that, here I am writing here molecular formula is given C9H10, and in the first case neglect the oxygen atom. Here you neglect oxygen atom, then molecular formula becomes C9H10, right? Neglect the oxygen atom I am using as a first method. Neglect the oxygen atom, now formula becomes C9H10. Now according to general formula of alkane, what is that? CnH2n plus 2. Then substitute the value of carbon whatever is there. So you write here C9H, 9 into 2 is 18 plus 2 is 20, right? C9H20. Then minus this figure from that, C9H10 divide by, if you subtract it, C9 get cancelled, 20 minus 10 remains as a 10, and then this value, whatever after the subtraction, whatever the value come, you divide by 2 by 2, we know that, and after dividing we are getting as a 5, right? And therefore site of unsaturation we got is a 5 in this case. Understood this? And if you calculate, suppose this is a 3 mark question, 1 mark is given for, or half mark is given for site of unsaturation. It is very essential you do the rough work on the rough page. So how do you calculate that site of unsaturation? If you directly written as a site of unsaturation, you won't get any mark. So remember, how do you calculate the site of unsaturation? So here the site of unsaturation just now we have calculated it. Now the second point, UV data, UV. So the peak at 260 nanometer indicate presence of conjugated double bond, or we can say, or benzene ring or benzene ring. Benzene ring. Okay. Now, third point. What is that third point? Move on to the next one is the IR, right? IR, the absorption peak at 1715 per centimeter indicate presence of carbonyl group, presence of carbonyl group may be aldehyde or ketone, got it? And now fourth point, what is there? These are the IR values are given. The absorption bands at 1519, 1550, 1400 per centimeter indicate presence of aromatic ring, aromatic ring. Okay. Now let us move on to the PMR. What the PMR data are given over here, that we are going to see one by one point here. Let me clean the board once again over here. So now remember point number 5 here onward, 5, right? So now before that, here are the integrations, means signal heights are given. These are the signal height, the J value are given only one time, so from signal here you have to calculate first is a proton ratio. The signal height means integration heights are here. Remember, here is a 15 mm as to 10 mm as to what is that 25 mm, and from that you can calculate as a proton ratio, and proton ratio will be, you you divide this figure by the suitable factor, so 5, so it will come around is a 3 as to 2 as to 5, so total 10 protons. And look at here in the molecular formula, there are 10 protons, here also as a 10 protons, and therefore the value or the what we can call it as a these is given is a very correct one. So there is no printing mistake or at all. So you have to match. This is a total number of protons are 10, and molecular formula also containing as a 10, and so in this way you have to calculate as a proton ratio here, and therefore it comes as a 3 as to 2 as to 5, total becomes as a 10. So now point number 6 over here, the PMR, here you can write the singlet at 2.09 delta corresponding to 3 protons, indicate presence of what indicate presence of methyl group, because it is single, presence of methyl group, right? Now once again look at there, number 7. The singlet at 3.65 delta corresponding to 2 protons indicate presence of methylene proton, presence of CH2 methylene attached to aromatic ring. That type of the information we are getting over here. So most important one is this one. You have to, from the signal height you can calculate, because these are the integrations are given, and from that you can calculate as a proton ratio. So once you got the proton ratio, match whatever number of proton present in the molecular formula, and the total number comes out from the proton ratio, it means that that problem is a correct one. If that figure is not matching, it means there is some mistakes are there in the exam, in the problem. So let's see here, the point number 8 we are going to see here. Point number 8 here, singlet at 7.25 delta corresponding to 5 protons indicate presence of what? Presence of monosubstituted benzene ring, and by considering all above points, by considering all above points, the following structure is assigned to the given organic compound. And what is that? It should have a C9H10 and O, and therefore we know that the benzene ring is there, and which is a monosubstituted. So here CH2, then C double bond O and CS3. Look at this one. Look at 5 site of unsaturation, 4 for benzene and 1 for carbonyl group. So that is a 5 site of unsaturation. At the beginning we already calculated as a site of unsaturation, that perfectly matching. Then this gives a singlet at 7.20 aromatic protons are there, and this also has a this one 3.65, which is near the, because it is present in between as a two electron withdrawing group, and therefore value comes around as a 3.65 de-shielded, and this methyl group which is nearer to the carbonyl group, and therefore the value is 2.09. So here is a 7.25 delta values of aromatic compound. So this is the and singlet, this is also as a singlet, and this is also as a singlet. And if you see the PMR, number of signals present in the PMR, number of types of protons are present, 1, 2 and 3. There are 3 signals are there, and therefore there are 3 sets of protons are present in the compound. Look at, one set is this, second and third one, 3 sets of proton, 3 NMR signal, and their splitting pattern all are the singlet, and therefore they don't have any adjacent proton, and that's why we are getting as a singlet. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.